Hello everyone, this week's topic is Chapter 14 Recursion. It mainly covers how to create a recursive function, adding output statement for debugging, and recursive function examples. So what is a recursive function? A function call itself is a recursive function. How can we make a well-structured recursive function? A well-structured recursive function typically including three parts. First one is base case. So the base case acts as a crucial stopping point in a recursive function. It providing a direct result once a specific simple input is reached. So its job is to prevent infinite loop. The second part is the recursive step. The recursive step involves the function calling itself. We use the recursive steps to break the problem into smaller, similar subproblems. Actually, the third part is inside a recursive step. It's called changing variables or moving towards the base case. During every recursive call, it's essential that the input variable is modified. So this modification must progressively lead towards a defined base case. So it guarantees the function's termination. So we can use recursive binary search to find a specific atom within a sorted list. The core idea is to repeatedly divide a search interval in half. Here is how it works. It first checks if the range is valid. If valid, it finds the meta atom. If the meta atom is the target, then its index is returned, mid base case and end the recursion. Otherwise, it recursively searches the left half if the target is smaller, or the right half if the target is larger. This continues until the atom is found or the range becomes empty. So usually, recursive functions can be difficult to debug because of their nested calls or the flow of execution. So inserting print within the recursive function is a helpful technique to trace its execution. So here is an effective trick is to indent the output of the print statement based on the current level. So this visually represents how deeply nested the function calls are. So from the code, we can say in each recursive call, the indent variable is increased. So from the output, we can say the indented output clearly shows the sequence of the recursive calls and their depths. So make it easier to follow the program's logic. So recursion can actually quite handy for tackling mathematical problems like Fibonacci numbers and finding the greatest common divisor or computing factorials and even raising a base to a power. As you can see from these examples, mathematical problems that show these three features: repeat operations on smaller input, and a well-defined base case, and changing variables that approach the base case. And basically, recursion is really a good way to examine all the possible resulting problems. So here is a common call framework for recursion. This framework can be used for tasks like scrambling ladders or generating permutations, as well as for determining all possible paths. Let's run an example. Here we defined a basic call framework, and we use it. This basic call framework applied to print all permutations, also apply to scrambling, and also applies to distance travel. So let's run the code and see the output. Here let us to run a C. Let's C1, C2, C3, and we can see the basic call framework worked. Code 2 and distance travel. So okay, so this is my presentation. Thank you.